Thank you. Thank you.
2016 will be remembered for many different reasons.
Brexit means Brexit.
But whatever you thought of the events of this year, one thing is certain. It has been one of the most extraordinary years in space exploration.
Scientists are hailing a major discovery.
We have detected gravitational waves. We did it.
We have a spacecraft in orbit around Jupiter. I think people are rather pleased. I don't think I can remember a year which has delivered so much in terms of discovery and exploration. And we've been lucky enough to have a ringside seat for many of this year's remarkable events.
But the things that we report on are usually just the beginning of the story. The most exciting developments happen in the weeks and months that follow, as the serious science cuts in.
And so tonight, we're bringing you bang up to date with many of the biggest stories of 2016.
Welcome to the Sky at Night. There were 4 huge stories in 2016, and they've all seen significant new developments since we encountered them.
Tonight, we'll be looking back at these stories and revealing what's happened since we first reported on them. We'll be finding out more about Planet 9, the mysterious planet that may orbit in the very outer reaches of the solar system. We'll be investigating what the recent discovery of gravitational waves can tell us about the rest of the universe. And we'll be asking whether we're any closer to understanding Proxima b, the newly discovered and potentially Earth-like planet orbiting our nearest neighbouring star. And if Father Christmas brings you a new telescope, then we have good news. Pete is here with a quick guide to show you how to get the best from it.
But first we return to the biggest, most exciting mission of the year. One that would go where no spacecraft has gone before.
Back in July, I travelled to NASA's Jet Propulsion Laboratory to witness the arrival of the Juno probe as it entered orbit around Jupiter. It was to be the first craft to slip through Jupiter's vast and intense radiation belts, flying just 5,000 kilometres above the gas giant's cloud tops. No one knew if it would survive its entry into Jovian orbit. There it is, Juno right on time, into orbit, exactly as planned. After 5 years in space, Juno had made it into orbit within 1.2 seconds of the schedule, and the team was delighted. Congratulations!
Yay!
So it went well then?
It went great. Just, I mean, what were they, like 1 second off or something ridiculous?
Perfect.
It's perfect. So now we got the work is going to start. We get the data, we got to do the work.
In the 5 months since then, that work has started to deliver amazing results. Maggie met up with planetary scientist Lee Fletcher to find out how the data that Juno has already returned are transforming our understanding of the giant planet.
Lee, thanks so much for coming in. Now, Juno's gone into orbit about Jupiter, but it's had a few challenges.
Yes, when we first got into Jovian orbit back in July of 2016, we went into a 53-day orbit. The idea was we were looping high over the North Pole, then coming in very, very close to the planet and going back out over the South Pole. Now, the plan all along had been to fire the engines in October of this year to move us from that 53-day orbit into a 2-week orbit. Now, just before they were due to do that firing of the engine, they discovered that there was an issue with one of the valves. These are part of the propulsion system. They simply weren't opening and closing quite as quickly as they intended. So rather than take any risks, the program managers decided that they were going to postpone that burn, and at the moment we're staying in that 53-day orbit.
Now, to me, if you're in a 53-day orbit rather than a 2-week orbit, that seems like less data.
There's actually not a massive amount of difference. We'll get exactly the same science and we'll be covering exactly the same regions of the planet. It'll just take longer. So we're having to learn to be slightly more patient.
So what did you see from that first encounter?
Well, one of the wonderful things about Juno's orbit is it's giving us a vantage point that we have never, ever had before, the ability to look at the poles of Jupiter. And what I'm going to show you now is one of those first ever images of the south pole of Jupiter. You're seeing light being reflected from the day side just here and the night side down here. And as we zoom into this image, you can see the incredible structures that we're seeing here at the south pole. These are pinwheel storms that are presumably moving and migrating all over the South Pole itself. So this is the South Pole of Jupiter, but of course we saw the North Pole as well. Here it is, again, in this incredible detail. And if we just zoom in again, you see all of these pinwheel storms and cyclones that are taking place. No belt zone structure, but the thing I'm most excited about is what's going on up here. What you have is a cloud that's actually rising up from the night side of Jupiter, and it's getting so high in the planet's atmosphere that it's catching the dying rays of the sun as the sun is going down.
As well as the camera that operates invisible light, Juno is equipped with a whole suite of instruments to probe the planet in other ways, including its infrared imager that can penetrate Jupiter's cloud tops and reveal the vast scale of its aurorae.
When we first saw this image, it really knocked our socks off.
What a surprise.
What you are looking at is the aurora at the south pole of Jupiter, glowing because hydrogen ions are emitting their light as they're being bombarded by these electrons. It looks like a wall of fire, many times the size of the Earth. All of this incredible structure will be changing, ebbing and flowing over the course of just a few minutes.
Amazing stuff.
Now, what I can show you next are the very first observations from the microwave instrument on board Juno that's allowing us to see down below the clouds. Now, this image on the right-hand side is what you're familiar with. It's the banded structure of Jupiter.
We've got the red spot there. All of this looks very familiar.
Absolutely. So this is light being reflected from the topmost cloud decks. These slices that you see on the left are probing deeper and deeper and deeper down into the interior depths. If you look at these, it's obvious that we are actually seeing banded structure still down in the interior of Jupiter, down 300 kilometres below these cloud decks. So what this means is that the surface that we're seeing is just the tip of the iceberg, and that below that tip we're seeing an enormous circulation or atmospheric pattern that will keep atmospheric scientists going for years trying to interpret what is actually taking place.
Please come back again and tell us more about this amazing planet.
Will do. Thank you.
Thank you very much.
And that brings us to our second highlight of the year. At the end of August, just days before Juno's first close pass around Jupiter, news came of another tremendously exciting announcement.
Now, scientists are hailing a major discovery, a new planet which they've called Proxima b. At just 4 light years away, it's relatively close to us. It's roughly the same size as Earth, and because it's just the right distance away from its star, it could be the right temperature to have liquid water and possibly life.
The planet was found orbiting Proxima Centauri, our closest neighbouring star. At just over 4 light years away, it's close enough to imagine that we might one day be able to send a spacecraft there. Having a planet around Proxima is exciting, and pretty much everyone who studies exoplanets has scrambled to have their say about what it must really be like. In some ways, the planet is very different from the Earth. It orbits just 7.5 million kilometres from its star. That's roughly 20 times closer than the Earth is to the Sun. But because Proxima Centauri is so much cooler and dimmer than our Sun, the planet could be a similar temperature to the Earth. But being so close to its star could also create other problems. For example, it was thought that Proxima was a violent star, sending stellar flares towards the planet and making it an inhospitable place. But new research seems to show that it's no more violent than our Sun. But there remain many unknowns. We've no real idea what the planet is like. We can't observe it directly, And so everything we know, we've had to infer by watching the gravitational effect that it has on its star. And so a French team have tried to work out the planet's characteristics by using comparisons with the planets in our own solar system. If it has a large metallic core and a rocky mantle like Mercury does, then it's probably a little bit smaller than the Earth. But there are other, more exotic possibilities. It could be much bigger than the Earth, 1.4 times the size, in which case it would have to have a rocky core surrounded by a mantle of ice. And excitingly, the models suggest that the entire planet would then be covered in a vast ocean, 200 kilometers deep. All this speculation is great fun, but what we really need are more observations. But those observations will be extremely challenging. The planet is too small and too faint to be directly imaged with current telescopes, and so we must wait for the next generation of instruments before we can understand its true nature. The story of Proxima b has a long way to run.
Earlier this year, we asked for your help to identify a new class of comet hidden in the asteroid belt. These main belt comets are similar to ordinary asteroids, apart from they occasionally sprout tails. Very little is known about these strange objects, but their tails are almost certainly produced by pockets of ice, vaporizing as they are heated by the sun. That means that these main belt comets could represent a huge and previously unknown source of water in the inner solar system. But only a handful have been found, so we sent out a call to get you searching for them. We had a fantastic response, and Sky at Night viewers have contributed to identifying over 340,000 images to date. And from them, you identified these two, which appear to be producing tails, and which could be newly discovered comets. The next step is to observe these objects through the 8.2-metre Subaru telescope in Hawaii. This will hopefully occur early next year, and it will help the team to identify whether these really are main belt comets, and we'll bring you the results as soon as we have them.
The Comet Hunters project shows the power and the potential of everyone to make new discoveries. If you're inspired to become a stargazer yourself, or if you're getting a telescope for Christmas, Pete is here with some tips on how to get the best results.
Now, it's probably fair to say that astronomy isn't the cheapest of hobbies, but for a few £100 you can get some pretty decent kit, and there are plenty of manufacturers out there that make packages such as this. Now here I've got a very sturdy tripod at the bottom to hold everything very steady. On top of that I've got an equatorial mount head, and this one has a motor attached to it. Now this has the job of counteracting the Earth's rotation, so it keeps everything that I'm looking at through the eyepiece in exactly the same position. On top of that, I've got my telescope tube, and in this case, this is a 70mm refracting telescope. This is an ideal size to view the moon and deep sky objects such as open clusters and galaxies. To align the telescope properly, it needs to be balanced on the mount, and the mount needs to be pointed as accurately as possible at the celestial pole, which is close to the North Star. Once you've got your telescope set up, you need to leave it for about an hour to cool down to the outside temperature. That will also allow your eyes to adapt to the darkness. And then you're ready to start observing. And what I'm going to line up on tonight is the Andromeda Galaxy, Messier 31. That's our nearest, largest neighbouring galaxy. The Andromeda Galaxy is located almost overhead during early evening to the northeast of the Great Square of Pegasus. Use the right-hand side of the W-shaped constellation of Cassiopeia as a pointer to it. Point your scope at the galaxy, lining its elliptical haze up with the finder's crosshairs. If you want to take pictures of what you're observing, you can add an adapter ring that will connect most DSLR cameras to the telescope. But bear in mind that you'll have to rebalance the scope to take into account the weight of the camera. So try an ISO setting of between 400 and 1600. The higher you go, the noisier the end result will be. Also, an inexpensive shutter release cable like this is a great idea because it allows you to take your pictures without touching the camera and wobbling the telescope. Now, for a tracking mount like this, exposures between say 30 and 120 seconds are possible. The key to success is to experiment. There it is, the Andromeda Galaxy, and beautiful it looks too. Look at that, there's so much detail in there. I've got the core, I've got the spiral arms which are really faint, sort of going around the core, and I can see the dark dust lanes running through the galaxy as well. And I've got the satellite galaxies M32 and M110 also in that shot. Loads of detail, and with a fairly basic setup. It's amazing.
Our third highlight of the year was announced way back in January, and it took both the scientific community and the public by surprise.
A team of researchers from Caltech claimed that they had evidence for a ninth planet, hidden in the outer reaches of our solar system, far beyond the icy realm of the Kuiper Belt. I set out to demonstrate just how extreme this planet's orbit was. On this scale, every centimetre is about 35 million kilometres. The Earth is 150 million kilometres from the Sun. Pluto is 40 times further away, and the outer edge of the Kuiper Belt is still further. But Planet 9 is far beyond that. At the point of closest approach in its orbit, it sits 200 times further from the Sun than the Earth. That's a whopping 30 billion kilometres away from the Sun. But unlike the other planets, the proposed orbit of Planet 9 is not circular. Its highly eccentric path takes it much, much deeper into space. At its furthest possible point, it's aphelion. It could be as much as 1,200 times further from the Sun than the Earth. On this scale, it's 54 metres away. In reality, it would be 180 billion kilometres from the Sun.
This discovery was enormous news, but there was one crucial stumbling block. No one had actually seen Planet 9. Its existence had only been predicted by computer models that had been built by Caltech astronomers Mike Brown and Konstantin Batygin. They'd been trying to understand the unusual elliptical orbits of 6 distant objects out in the Kuiper Belt, seen here in pink. They found that the only way they could replicate these orbits was if there was a 9th planet, orbiting far beyond Neptune. When I met Mike shortly after the announcement in January, he explained to me that the next challenge would be to find the planet.
Clear sky, sort of. Where is it? Where's this planet?
Well, we know its path across the sky. We know its orbit, so we know the path. And the path across the sky goes from somewhere over here, up across here, right through the middle of Orion and Taurus, and then down south across this way. And then, of course, all the way back around. We actually also know that around Orion and Taurus is where it's the most distant from the Sun. And we think that's where it is. We think that the places that are closer to the Sun, it'd be too bright. We would have seen it.
I mean, we're not talking amateur telescopes here to find this.
No, in the end, it's going to take us some time on the biggest telescopes in the world. But with the biggest telescopes in the world, it is well within range, and we'll be able to find it.
It's up there somewhere, probably.
Right there.
Many astronomers are yet to be convinced, and so I recently caught up with Mike again to see how the search was going.
Hello. Hey Mike, it's Chris. How are you?
Good, Chris. How are you?
Yeah, nice to see you. So, look, I'm not going to waste any time. Have you found Planet 9 yet?
No.
Excellent. Thank you. What progress do you have to report?
My favorite one that we realized just this last summer is something that has been known since 1850 and has had no explanation, which is if you look at the planets of our solar system, all 8 planets, they're in a disk, and that disk, the inclinations, the amount that they're tilted relative to each other, is less than 1 degree on average. So all 8 planets are within this one little 1 degree disk. The sun is tilted from that disk by about 6 degrees. It's really a strange thing. No one has had a very good explanation for 160 years. And in fact, it's been so unexplainable that most people don't even realize that it's true. So we quickly sat down and did this calculation to figure it out and realized that our prediction of Planet 9 and of where Planet 9 is predicts about a 6 degree tilt, just like the tilt that we see, and the exact direction that the sun is actually tilted. It was one of those remarkable moments where you do this calculation not knowing what the answer is going to be, and it comes out exactly what you were hoping it was going to be.
So lots of people are looking. Have you had skeptical reaction as well? Clearly not everyone's as sure as you are. What have the negative reactions been? Are people still questioning whether this is just chance, these alignments?
Yeah, so scientists, as a rule, are a skeptical tribe. And if you're going to be skeptical of anything, you should be skeptical of somebody claiming there's a planet out in the outer solar system, because people have been claiming this for approximately the last 165 years, and every time it's been a mistake. So there are people trying very hard to show that it's not true. So far, I haven't seen anything that has been convincingly showing that it's not really out there.
Well, just before we let you go, to get back to trying to find this thing for us, I'm going to make you bet, I think, next year, 2017?
At the beginning of this year, I was cautious, and I said 5 years. And now, I tell you, we have narrowed down the search area to such a small area with these calculations. I'm going to guess that next year's the year. I feel optimistic.
Okay, well, we'll talk to you then. Good luck.
All right, thank you very much.
Thanks, Mike. Mike certainly sounds convinced, even more than he did at the start of the year, and the evidence does seem to be piling up. So let's hope he's right, and 2017 is the year that we find Planet 9.
Our fourth and final story comes from much, much deeper in space. Back in January, Planet 9 was described as potentially the discovery of the century. But then just 3 weeks later, scientists at the Advanced LIGO Instrument in the States made an even bigger announcement.
Unraveling the secrets of the universe, the most important scientific discovery for a generation.
Scientists in the United States have announced they have discovered gravitational waves.
Einstein was right after all. Gravitational waves ripple through space and time.
Gravitational waves were a key feature of Einstein's theory of general relativity. And the fact that they were discovered exactly a century after he predicted them strengthens his theory. But gravitational waves gives us so much more, because they allow us to see some of the most exotic bodies in the universe. Because what LIGO had detected was the collision between 2 black holes. Black holes are difficult to study by conventional means because they do not emit any light. But the LIGO measurements suddenly gave us a way to observe exactly what happens when black holes collide. 1.3 billion light-years away, the 2 black holes, 36 and 29 times the mass of the Sun, had been orbiting each other in a binary system before colliding with such force that they sent tremors rippling through space-time. But by the time they reached Earth, the waves had dissipated so much they caused a disturbance in LIGO's detectors that was only 1/1000th the width of a proton. A lot has happened since we brought you that first detection. In fact, just 3 months later, another collision between black holes was detected, and then a third. But The signal for that one was a bit too weak to get full confirmation. But this collection of collisions gives us an indication that these events, which we thought were rare, may be relatively common. And these new discoveries are also causing us to reassess our ideas about the nature and formation of black holes. The data have revealed that some black holes spin at enormous speeds, 10% of the speed of light, much faster than we expected. And then there's a problem that the black holes detected in the first collision are far too massive to exist in a binary system. Black holes form from the collapse of massive stars at the end of their lifetimes. It had always been assumed that black hole pairs form from binary star systems. But the black holes in the LIGO observations are so vast, they must have formed from stars that were too big to survive as binaries. They would have fallen into each other and merged, long before they could have formed black holes. So we need a new model to understand how black holes collide. It may be that instead of forming in a binary star system, that the two black holes formed independently, maybe in a dense star cluster, then gravitated towards each other, forming a binary pair, which then collapsed.
What's really exciting about this gravitational wave discovery is that it lets us see things that were previously hidden. Instead of relying on light in looking only at things that shine, we have a whole new way to observe the universe. LIGO has just begun its second run, and detections are expected to come thick and fast over the coming months and years. We don't know what these next observations will reveal, but we do know that when people look back at this first discovery in 2016, they'll see it as a great moment in the history of astronomy, as transformative as the invention of the radio telescope.
That brings us to the end of the 4 major stories we covered this year. But there have been many other exciting events that slipped by without fanfare.
In September, we saw the launch of OSIRIS-REx, an ambitious new mission to collect a sample of an asteroid and return it to Earth. Elsewhere in the solar system, it's been a good year for discovering water. An ice volcano twice the size of Everest was found on the dwarf planet Ceres. Plumes of water have been detected erupting from Jupiter's moon Europa. And there's fresh evidence for the existence of a subsurface ocean on Pluto.
Further afield, astronomers have discovered that there are 10 times more galaxies in the observable universe than first thought. Some 2 trillion of them. One of them, Dragonfly 44, has been found to be made of 99.9% dark matter, making it the largest dark matter galaxy ever observed. 2016 is coming to an end, but there's lots of exciting stuff for the new year.
Yes, we've got the launch of not 1 but 2 exoplanet missions, a total solar eclipse in the US, more from LIGO, and I'm looking forward to Curiosity climbing the slopes of Mount Sharp. But what are you most excited by?
Well, for me, it's all about the end of Cassini. It's been an epic mission, and now it's coming to an end, and it's going to be a grand finale as the spacecraft plunges into the depths of Saturn. What a way to go!
Yeah, it's a shame it's got to end, but it will be spectacular. That's it from us from this year, but we'll be back in January, so you don't have long to wait. And in the meantime, don't forget to go to the website to check out this month's guide to the night sky.
And as usual, get outside and get looking up.
Good night.
Super telescopes coming up on BBC4, Eyes to the Skies for Horizon next.